Hi everybody, this is Eugene O'Loughlin lecturing computing at the National College of Ireland, and welcome to my series of short how-to videos. In this video we're going to learn how to perform a chi-square test in Excel 2010. So first of all, let's remind ourselves what a chi-square test is used for. It's used to tell us if there's a difference between observed and expected values in an experiment. And our null hypothesis in a chi-square test is that there is no, that's the HO, is that there's no difference between the observed O and the expected values in our test. And the alternative then, of course, is the opposite of that, is that the H1 is that there is a difference between the observed and the expected values. And there's two ways in Excel to calculate chi-squared. The first is a manual calculation, which I'm going to do first. And then there's a formula within Excel which also shows you how to do a chi-square test, and it's based on probability, and we'll do that at the end of the video. So here's my formula for calculating chi-squared in my brown box on the right hand side, and what it does is it tells us to take the observed minus the expected values, square them, divide by the expected values, and then sum them all up, and that gives us our chi-squared. And I've set my table up over here to do just that. So supposing I'm a manufacturer of dice for a casino, and I want to check that my dice are fair and that the casino will have no problems with them. And a dice, as you know, each die has 6 sides. So if I roll my dice 600 times, I would expect that each side would show up 100 times if it was a fair random dice. And these are my expected numbers here on row number 4. So for each side, I'm expecting a value of 100. Now let's say I go ahead and conduct an experiment where I do actually roll the dice 600 times, and I record the number of times each number shows up. And the observed numbers here are in row number 3, so you can see that number 1 has showed up 89 times, number 2 95 times, and so on up to number 6, which has shown up 117 times. And so I might be a little bit suspicious of these numbers, that there might be a fault in my manufacturing process that's causing, for example, the number 6 to appear a disproportionate number of times. So I want to use a chi-square test to see if there is a difference between the observed and the expected. That's, in other words, to reject my null hypothesis. So let's go ahead and do these calculations. Let's do the manual one first. So in my table over here, I need to calculate first of all the deviation between the observed and the expected. So that's a straightforward calculation. Type in equals the O number, 89 in this case, minus the expected number, that's 100, and press enter. And that gives us an answer of minus 11. And I'm going to use Excel's autofill tool to copy that formula for the remaining 5 values. Now I need to square these, so I just type in equals the value I want to square, minus 11 in this case. I'm going to use the hat symbol, which is the symbol over the number 6 key on your keypad. And as I'm going to square it, I'm going to type in number 2 here and press enter. So minus 11 squared is 121. And copy that formula with autofill to the remaining cells as well. And finally, I need to divide my deviation squared by the expected value. So again, a straightforward formula. Type in equals my deviation squared, 121 in this case, divided by the expected value, which is 100, and press enter. And for the final time, use Excel's autofill tool to copy that over for the remaining values. So now, as far as my formula is concerned, I've calculated O minus E squared divided by E for each of my 6 values, and now I need to just sum those to give me my chi-squared value. So over here in my box on the left hand side, I have in cell B13 where I want to insert my chi-squared value. So I'm going to type in here equals the sum of the values that I have just calculated. So select them all with your mouse, the 6 values, put in a closing bracket and press enter. And this gives me a chi-squared value for my observed and expected numbers of 4.7. Now I need to know, is that value a significant value at the 0.05 value for alpha? And before I can check this, I need to work out the number of degrees of freedom for my experiment. So all I've got to do is remember the -1 rule here. I have 6 sides to my dice. That gives us 6 variables. Therefore, 6 minus 1 gives us 5 degrees of freedom. I'm typing that in cell B10. So now I can look up my chi-square distribution table to tell us where our value falls. So this distribution table here is from Wikipedia. I've got 5 degrees of freedom, so I'm going across row number labeled number 5 here. And I'm working at the probability, the significance level of 0.05, and I've highlighted here where the row and the column intersect, and it gives me a critical value of 11.07. So let's type in that critical value here, 11.07. So now I want to know, can I reject or accept the null hypothesis? With a chi-square test, if my chi-squared value is greater than my critical value, well, then I can reject the null hypothesis that there's no difference between the observed and the mean. But as you can see here in this particular case here, we can see that our chi-squared value of 4.7 is quite a bit less than our critical value of 11.07. Therefore, we do not have enough evidence to reject the null hypothesis that there's no difference between the observed and the expected. And that tells us, in other words, that there is statistically no difference between them, between the observed and the expected. So reject HO, in this case I'm going to say no. Now we can also use a formula within Excel, and in my formulas ribbons up here, under more functions, choose the statistical option, and this gives you a list of statistics that Excel allows us to do, and you can see that there's quite a few chi-squared ones listed here. And the one that we want to use is chi-squared. Let me just select the right box here before I do that. Is chi-squared.test. And as you can see here in the functions argument window, all it needs to know is what the actual or the observed numbers are and the expected range or the expected numbers. So the actual numbers I'm going to select with my mouse here across the top. That's in my table is the observed, B3 to G3. And in the expected range, I'm going to select my items in row number 4. So that's B4 to G4. And that's all I need to do. Click OK. And it gives me, this is not a chi-squared value, this is a probability value, and the probability of 0.453578. And if my probability is less than my alpha value, in my case 0.05, I can reject the null hypothesis. As you can see, my probability value of 0.453578 is greater than my alpha value of 0.05, and therefore I do not have enough evidence to reject the null hypothesis. In other words, as my manual calculation has shown, we have statistically no difference between the observed and expected values here. So once again, I will not reject the null hypothesis, and I'm just typing in no here. So whether you've used the manual calculation, which is the traditional method of calculating chi-squared, or the Excel formula, you should come up with the same decision whether to accept or reject the null hypothesis to tell you if there is a difference between observed and expected numbers. So that's how you perform a chi-square test in Excel 2010. I hope you found this video useful. Thank you for your attention.